How do? Today we're going to be looking at the Music Thing Modular Turing machine with a mind to get an understanding of what's happening with the volts expander. We're doing this in the VCV Rack environment just as a convenient way to see scope outputs and screen capture the video so it's nice and straightforward and easy to understand. I personally own the hardware version of this module and the expanders from a DIY kit. Great kit for doing generative kind of patching within the Eurorack environment. So to be able to understand the volts, it's probably good to just quickly cover off on what the Turing machine is. At its heart, it is a random sequence generator, and it does this by converting a byte of information to produce a voltage out that can be used as an 8-step, 12, 16, or 6, 5, 4, 3, 2 step sequence. It produces a random sequence by populating this byte with a randomly generated bit from the most significant bit to the least. And using a shift register, it pushes the random bit on the most significant down to the lowest significant bit. This byte is represented here as well, with 1 being the most significant to 7 being the least. 1, 2, 3, 4, 5, 6, 7. There's actually got 8. 1, 2, 3, 4, 5, 6, 7, 8. So these 7 bits of information are represented here with these 7 of the byte. The volts knobs or pots are unlabeled, so it's a little bit esoteric what's going on with those. So, as I said, the byte of information is translates to a voltage out from the Turing machine. The voltage out from the volts expander somewhat relates to that output, but not directly. We're not going to be clocking this. What we're instead going to do is use the noise source as a one-shot so we can step through and look step by step at the sequence as it's being produced, as if it were a paused clock signal. So you can see that that green LED indicator is moved on, that we're stepping through, and straight away. So before we go anywhere, let's have a quick look at what's going on. Randomly, the most significant bit has now gone high. Previously it did not. So this represents 1, 0, 0, 0, 0, 0, 0, 0. You can also see, as I said, 1 represents the most significant bit on the pulse expander. It is also now high. What has happened at the output of the Turing machine is it's now gone to 2.516 volts, whereas the output from the volts expander has gone to 0.997 volts. Straight away, if we start to play with these knobs or potentiometers, 5, 4, 3 and 2, nothing happens. Cutting to the chase, this pot is only active when the most significant bit is illuminated, or if you like, when the 1 on the pulse expander is illuminated. They're the same thing, but it's just for convenience, it might be the easiest way to look at it. So with that pot at 12 o'clock, turning down will lower the volts output or raise it as you go. So keeping it at 12 o'clock is the best way to demonstrate it. When I step this sequence again, this bit will move to the second most significant place, and the most significant bit will either go high or low depending on the random generation. So we'll do that now. Okay, randomly that was held low, and it is now stepped to the second position. And we can see that pulse expander 1 is no longer illuminated, and 2 is. Logically then, we'll have a look. Output is 1.258. That byte now translates to a different voltage out, and we're at 1.008 volts. That is because now the position of pot 2 has a bearing on that output, whereas the position of 1 does not. It is that indication there that makes a difference. So again, we'll throw another one shot, and we can expect that this bit will move to this position, this bit will move to that position, and the most significant bit will be either high or low. In this case it was low, so we've got 0, 0, 1, 0, 0, 1. And as you're easily aware now, pot 1, which corresponds with expander, pulses expander port 1, the most significant bit, has no impact on the output voltage of volts, nor does pot or knob 2, but pot 3 does. So now what I'll do is just do an experiment where we turn all of the voltages down, and the output voltage for the volts expander is now 0, as opposed to 0.629 volts for the Turing machine itself. We know that this bit, with the next step of the one shot, or a clock if it were clocked, will be high, so we know that this will have an impact on the sequence. So we know it will go up. We also don't know if the most significant bit will be high or low, so let's also throw that up there, but we know these will have no impact. So we will reclock it again. Right, so this has had no impact because it is still 0, but now, as predicted, we knew that we would have an output voltage being affected by pot number 4, because we knew that due to the shift register that high would move from 3 to 4, or from the third most to the fourth most significant bit in the shift register. And what that has meant is we've got an output of 1.997. So we've got one last chance to try and see the effect here, leaving 2, 3 and 4 at 0, knowing that the fifth most significant bit, or the fifth corresponding port from the expander, will now activate this knob or pot, and hoping that we'll see some kind of impact here when the most significant bit has a new random generation. And this time it has worked. So we knew that this pot was going to control the output here, but now, because randomly this has now gone high, 1 and 5, 1 and 5, the output voltage is now 4 volts. So we've got the full range. If I turn this all the way down, it's 2 volts, the 1.997, or close enough. If I turn the fifth one down and leave that one up, it's 2 volts. So it looks like every time the knob is fully turned clockwise and activated, it amounts to about 2 volts worth of output. Let's try one more. Again, this has no impact because it's now moved into the 6th and 7th points. We've only got the first 5. 1 and 2, again 4 volts. Let's go for a third time. Hopefully we can see a high there. And we have. So if our theory is correct, if I turn this pot all the way up, it'll be 6 volts. 6 volts it is. Whereas the output from the actual Turing machine itself is only 4.443 volts. So that pretty much sums up or demystifies what's happening if it wasn't obvious, which it kind of isn't because they're not labelled, but you can think of it for ease as this knob or pot is only active when your port 1 of your pulses expander is high, equally 2 to 2, 3 to 3, 4 to 4, and 5 to 5, which again directly relates to the first, second, third, fourth, and fifth most significant bits of the byte as generated randomly by the Turing machine. And that's how we can say that the voltage out from both the Turing machine and the volts expander is related but then also controllable in its own right. So hopefully that sort of demystifies and clears it up. If you were interested or wanting to know how it worked a little bit better, or if you didn't want to know, now you possibly do anyway. Have fun and happy patching. Catch you next time.